Okay, so let's start by understanding what exactly is document parsing and why do we need it. If I go back to my diagram here, where is it? Yeah. So these documents should be converted into chunks, and these chunks will be converted to tokens, vectors, and embeddings. But the very first step is you need to have the documents, right? So to create a vector database, you need embeddings. What are these embeddings? These are documents. From where am I going to get all these different documents? There are many different places. First one is PDFs, Excel, Word files, text files, JSON files, XML files, HTML files, web search results, and documentation from SharePoint, Confluence pages. There are many different sources from which I can obtain my documents. So to get started, I'll teach you how can we work with PDFs and how can we read the document and then create chunks, tokens, vectors, and embeddings with the help of PDFs. So let's start with this one. So to deal with that, we have PyPDF as one of the library. So PyPDF is a very popular library whenever we are working with PDF files. If you want to read a PDF file, make some changes, read some metadata about it, then we can go for PyPDF. But for handling all of the other file types, you cannot use PyPDF. So for each one of them, you can use different libraries. For Excel, you can use pandas. For Word files, you can use docx library. For text files, you can use text, JSON, HTML, and XML. For all these four, you can use the basic Python built-in read function. For web search result, you can use Beautiful Soup or Selenium. So in that way, for different inputs, for different types, you can rely on different libraries to read the content. But the most important part, the final goal is to read everything, put it in one giant string. That string is what we call as document. So whatever paragraphs we have inside of the PDF, we are going to read them using this PyPDF. So to achieve this, uh, here I've got a very simple PDF that I was able to find online, sample local PDF. This one, it's a very dummy PDF actually. It doesn't have anything. Only this first part uh, is in English, I believe, only up to here, and the rest of it is just placeholder text written in Latin. I'm not even going to bother translating it or anything, but this is just a placeholder text to read everything to build our proper pipeline. So what we'll be doing is we'll read all of the content, we'll convert the document into small chunks. Okay, let's start by doing that in VS Code. Mhm. Okay, you need to install PyPDF. I'm pretty sure I already have it installed. Next, we will import the PyPDF library. We'll import the PyPDF library, we'll give the PDF path, we'll read it, and then we will extract all of the text and we'll print it page by page. Okay. Yeah, you can see in the first page, it's a sample PDF created for testing PDF object. This PDF is 3 pages long, 3 long pages. Did I close it? Yes. Yeah, you can see sample PDF created for testing PDF. This PDF is 3 pages long, 3 long pages or 3 short pages if you are optimistic, etc. etc. So we were able to read all of that as it is, page by page. And why do you see this one in a separate line and sample PDF in a separate line, that is because it is the page number. So that is in a separate line because it is part of the footer. And similarly, you'll have a header whenever you're creating a PDF. If you are using Word for creating this PDF, if you're expert in that part, you'll already know you can add a footer, you can add a header, and you can attach some metadata like the title, author, and create a date, last updated date, comments. You can upload all these different things, save it as a proper PDF. You can also add security like the file password and all. So using PyPDF, you can uh, properly read all those different aspects. And here, if you see, this is the page number, and we are getting the actual content. So it will print the header first, next the footer, next the actual content. Since we don't have a header, it is not printing anything. We have a footer, which is page number, so it is printing page number, then the actual content. Yeah, there you go. So this is how we can read a document using PyPDF. Next, page-wise parsing is the same thing actually. Yeah, you can see page one, page two. Now we have extracting the metadata. It is able to extract the title, but there's no author or creator attached to that PDF, not inside of the PDF. Okay, while creating the actual document itself, you can attach all this metadata to the PDF document. And for this particular document, whatever I'm using, it doesn't have any author or creator tag. So it is none, but it has a title, of course. So it has given me the title. Okay. Now, recursive character splitting. If I go back to the diagram, so we have document. These are paragraphs. We need to create them into chunks. What are chunks? Chunks are sentences, right? So to do this part, we will use recursive character text splitter. So we are going to use this recursive character text splitter module from LangChain library, which is quite popular way of creating your chunks. To be honest, there are many different ways of creating these chunks. I'll tell you some of these methods in a few seconds, but let's use this recursive character text splitter. I'll take this, I'll copy, paste. So if you see from langchain.textsplitter, I'm importing the recursive character text splitter and I'm reading my PDF. I'm taking all of the text, I'm combining all of them together into this variable called as full text. Then I'll create an object of this recursive character text splitter. Chunk size is 512, chunk overlap is 50. I'll explain what these two are in a few seconds. And finally, we have the chunks part where we are going to pass our full text. Then let's print each chunk and we can see. So if you see, the whole document has been split into 22 different sentences. Each sentence or each chunk can be seen here. Now, what is 512? There are 512 characters in each chunk at maximum. If I go back to the whiteboard, let me copy all of this. Yeah. So this is my entire document. So what we do is we have two different things called as chunk size, chunk overlap. So we have these two parameters, chunk size and chunk overlap. Let's see what they are. So in each chunk, I've given the chunk size as 5 and 2 and chunk overlap as 50. Okay, let's create chunks here. Let's assume that this piece, can't I say transparency? Send back. Yeah. So this piece has 512 characters. This one sentence has 512 characters. Let's assume that. Okay. Next. This also has 512 characters. The blue one. Okay. Let's create one more small and final one. I'll put it in yellow. You go back. So this thing also has 512 characters, right? But the problem here is, uh, if I have some information, if you see here, the full stop is over here, but the ELIT word is in the blue color chunk, but the red color chunk is ending over here itself. Let's say in a resume, we have done the same process, education related information. Let's suppose the college name went into the skills section chunk. So there are two chunks, skills and education. In the skills chunk, you have the college name. So it went out in the other chunk. And in this one, you have your school, you have your intermediate college, but nothing about your bachelor's or master's. They are in a different chunk. Now, when you're writing your query, you will fetch this one, the education query, not the skills one, but the information that you want, the actual college name from which the candidate has done the degree, that is present in a different chunk. This is a huge problem. So this is where we have something called as chunk overlap, where we make sure that we are capturing 50 characters from here as well. So which means, uh, let's take this one also. This will be in pink. So which means this elite word is going to be present. So which means that elite word is going to be present in both the chunks, in the pink one and also in the blue one. Similarly, if I'm using the chunk overlap properly in the resume example, the college name will be present in both the chunks, the skills chunk and also in the education chunk. So this is chunk size and chunk overlap. Depending upon how huge your document is or how small your document is, you can choose your chunk size. For example, if you're working with a 3000 page PDF, 4000 page PDF, 10,000 page PDF, in those situations, 512 is such a small size. You have to go for at least 2000 as the chunk size. If you go with 2000, then all this will become one chunk. Because usually, if you have such a huge document, it's very much likely that all of the relevant information will be in one paragraph, right? And depending upon the size of the paragraph, you can take a rough estimate and you can say, okay, I want 2000 as my chunk size. Chunk overlap maybe 100 or 150. So depending upon the length of your context, you choose your chunk size and chunk overlap properly. Okay, so we have created all these different chunks. And what is the next step? Next step is to create tokens, vectors, and embeddings. But before we do that, there are few other ways in which you can create these chunks. So right now we are taking the entire paragraph as it is. We are breaking it into small pieces and then we are storing it in vector database. But there are few more things that you can do which will enhance your RAG capabilities. Let's try to discuss what they are. So how to improve your document parsing? Let's assume that you have already parsed your document, you read all of your text, and then you have created these small chunks. So in this example, I've got 22 different chunks. What I can do is I can create a summary of each chunk and entity extraction. So these are two different steps that you can implement along with your original chunk. So let's say you have, so let's say you are parsing a document. Take the same document, for example. There is this one. Let's assume that this is some kind of an invoice. So what you can do is you can parse all of that information that will be in your original chunk, of course. Then you can use some sort of a LLM or a small language model, SLM, to create a summary of that chunk. Not for the whole document, but only for that one chunk, you will create a summary of it. Then you will then you will extract the entities from that chunk. So entities can be any important information like invoice number, invoice date, invoice address. If it is a resume, there are a number of entities like the uh, number of years of experience, previous company name, job role, overall years of experience. These are all different entities. Or if you take any other medical related document, you will have the blood pressure, the heart rate, the other medical health conditions, the name, gender, all are different entities. You can extract all those entities and then you can keep them aside. The reason why we have to do all that is because for querying, it is going to be much more easy. So let's say you are dealing with uh, 200 documents. You have created chunks per document. Each chunk will have uh, content, summary, and so each chunk will have all these three. So let's say if your user is asking, give me a summary, then you can implement a separate pipeline, a separate logic for your retrieval function, where if the user query has the word summary, then you don't have to do any querying on the Chroma database. You don't have to do semantic search, cosine similarity, etc., etc. You can simply fetch the summary of this particular document and you can send it to the LLM directly. Or if the user is asking for some sort of a entity extraction, for example, they will upload a document and they want to extract all of the entities directly, then you can use this entity, uh, how to say, this entity metadata, sorry, not metadata, these in entity or what vectors. Yeah, you can use these entity vectors and you can show them to the user directly. You can build a separate Python function for summary, separate Python function for entity, separate Python function for content as well. So these are some of the different things that you can do for each chunk. But keep in mind, you're doing this for every chunk, which means if your chunk size is small, you don't have to create a summary. You don't have to create entities. You can just simply put it as it is, because for smaller chunks, it's very easy to do the semantic searching or cosine similarity, and it's much more faster. But if you have huge chunks, for example, if you're dealing with a 4,000 page document, each chunk size is somewhere about 300 and 400. In those situations, you will not just 300, 400, each chunk size will be in like 13,000, 14,000 characters per chunk, because it's a 4,000 page document, right? So in those situations, it's much more suitable if you create the summary and the entities separately, store all of them as uh, different vectors in your vector database. But if you're dealing with a very small document, then you can simply ignore all of these and you can take the original chunk, create it into embedding, and then store it directly in your vector database. So this is about recursive character text splitter. So we took the text, we have broken it into smaller pieces. Next, in the next lesson, we are going to learn how to create embeddings out of it and store it in ChromaDB. And using PyPDF, you can also decipher where, sorry, not decipher, decrypt, where if it is password protected, you can enter your password here and then it will be able to open the PDF using your password. So these are some advanced use cases, extracting tables from PDF and combining with semantic parsing. Along with tables, we also have to take a look at images as well. So in the PDF that I've shown you, this one, it has absolutely zero tables. But in the real world, you'll have PDF documents with tables, you'll have documents with graphs, you'll have documents with images. So these are three different problems that you will face. So to extract tables, you can use Camelot, or if you're going with, where is it? Where is it? Where is it? Oh, deleted. Okay. So if you're going with form recognizers or Azure Document Intelligence, if you're going with this one, you can ask your form recognizer to extract all of your entities. You can ask your form recognizer to extract all the tables directly. So it is quite powerful. So for extracting tables, you can use Camelot Python library, or you can use the document intelligence also. Combined with semantic parsing. Before we go into semantic parsing, we covered tables, but there are two more problems that you will face. Let's put it here. Original chunk, tables. So whatever tables you have, they need to be converted into proper vector representations. Or in fact, I would say if you're building a very, very extremely robust pipeline, then store all of your tables with some proper metadata. And then based on the user question, you need to query the entire table as it is and pass it to the LLM model. You can pass the entire table, or you can write some pandas SQL query and then shorten the results and then you can send it. But the suggestion would be to somehow get the tables directly. Don't do any vector searching or anything. Get the entire chunk as it is. Okay. Tables, graphs, images. So these are three different things. Images and graphs are slightly different in this situation because in a PDF, graph is also considered as an image, but the information that you have inside of image is different from what you have inside of a graph. Inside of graph, it's a graph basically, but inside of image, you will have people standing, sitting, doing some action. All those things are under images. So to handle these three situations, so the first one I've explained you can use Camelot, you can use document intelligence. For understanding graphs and images, there are two different methods. For graphs, the easiest and the most accurate representation can be done using another LLM model. So which means if you're able to extract the graph properly from PDF, then you can send it to an LLM model, ask it to summarize this graph or explain that graph in detail and use that text, use the summary, use the representation, use the LLM output as your chunk. Same thing goes for images as well. You can ask your LLM model to explain what is happening inside of that image. So these are all the different things that you can create per every chunk. Along with all of these, if I have to take the original chunk, I can also enhance it by doing something called as semantic parsing. There are many different libraries who are trying to achieve this, but if you take a look at Markdown format, Let's write a blog on Gen AI. So it wrote this nice blog for me. Markdown live preview. Yeah, if I paste it here, you can see this is the blog, right? So let's assume that this is what I got after parsing the PDF file. I'll take this, I'll create small chunks. Let's assume that this is one chunk, or let's assume this is one chunk. Okay. In this selected region, let me zoom in a bit. Oh, I don't think I can zoom in. Okay. So in this selected region, it doesn't know under what heading do I have this chunk. If I go into this portion, if I'm capturing only this selected part, only this highlighted part, or this one, okay, let's take only this one. It has absolutely no idea what is the heading, what is the subheading. In those situations, there are chances that you will miss out the information. When you're querying, you might not get the accurate results. So if you take the same resume example, mm, let's draw it here. You have a resume, you have divided that resume into small pieces. This is your personal info, or also contact person details, candidate details. Sorry. Okay. And here you have your work experience, and here you have your education or skills. Finally, you have your education. And let's suppose your education heading is sitting here, but the content is over here, and your chunk is capturing only this portion. Let's assume that this guy has written what he has done in the college, and that portion is being captured here, but that portion has it doesn't cover the actual heading. So if I take only this one chunk individually, and if I look at it, I don't know from which part of the whole resume I was able to extract this chunk. If I look at it like this, I can see that it was extracted from the college details. Yeah. So if I look at it like this, I know that this green chunk has been extracted from the college details. But if I look at the chunks separately, there's no heading at all. So I don't know from which piece or which portion of the resume this chunk was extracted. To solve that problem, what many people are trying to do is they're trying to convert everything into Markdown format. Or if you already have a Markdown file, well and good. Or if you have a HTML or XML file, they are trying to convert that into Markdown, the other way around. Then they will take the heading name and they'll attach it with every single chunk. Whatever chunk you're creating, it will capture the heading name. It will combine both of them, heading, subheading, title, all the three. This is what we call as semantic parsing. So the semantic parsing, as of now, there is not any well-established, robust library which is able to do this. So this is such a new requirement in the market right now. But this is something that many people are trying to implement in different ways so that the vector database will capture more and more information. One thing that you have to keep in mind is it's always okay to have duplicate information in your vector database. So let's say you're storing all of these different things, different vector representations for just one chunk. So you take this green part, Whatever information I've got inside of this green part, the same thing will be used as original chunk. The same thing will be used as semantic parsing. The same thing will be in summary, entity, table, graph, images. It's totally fine. It's completely okay to have duplicate information inside of your vector database. And that is the reason why we will use top n value. We don't just fetch only one or two vectors. We'll fetch the top n most relevant vectors. So which means if I'm asking, where did this person do his bachelor's or master's? Then I'm fetching the top n. The top n will cover all the relevant information. So it's always okay to have duplicate information. But in such cases, you need to go for a higher top n value, which means it will slightly increase the token count in your LLM calling for the API request, and you'll be paying slightly higher amount, but the accuracy is going to be improved. Okay, I believe we covered many things with document parsing. We have also covered the limitation as well. So PyPDF doesn't support any table parsing. For that, we need to go for other solutions. Okay, next we are going to, I believe we have also covered semantic parsing, which I've already explained. Yeah, heading one, subheading, and then the actual chunk. Heading one, subheading, and then the actual chunk. Yeah, let's go ahead and skip to the next lesson, which is document parsing using form recognizer. See you in the next video. Thank you.